Good morning and Jai Hind. Today I am going to talk about some properties of quadrilateral. You'll see that in the last video I have talked of different properties of quadrilateral. Now I am going to revise those properties so that we can use those properties in this fourth exercise of understanding quadrilateral. So I am going to start with different properties of quadrilateral which we have already studied in the last exercise. We have seen that we have already used the properties of parallelogram, and now I'm just recapitulating the properties of different quadrilaterals here. First of all, I'll start with quadrilateral, which means four-sided closed figure, four-sided closed figure or four-sided polygon is called the quadrilateral. Now when you see that if a quadrilateral has only single pair of parallel side, quadrilateral with one pair of parallel side, quadrilateral with one pair of parallel side is called as trapezium. Although for trapezium I have not discussed in the last video because trapezium related much questions are not there, although I'll say no question is there related to the trapezium. So I'm just telling you because this is also one type of quadrilateral. When you see only a single pair of parallel side, then those type of figure is called as trapezium. There will be only one pair of parallel side. Now if you see a quadrilateral with one pair of parallel side and where non-parallel sides are equal, then this type of trapezium is called as isosceles trapezium. It means quadrilateral with one pair of parallel side and whose non-parallel sides are equal. Suppose if I take it as A, B, C, D. So AD is equals to BC. This is non-parallel side. These are non-parallel sides. Non-parallel sides. So when the non-parallel sides of a trapezium are equal, then we call it as isosceles trapezium. And the important property of isosceles trapezium is that its base angles are always equal. The base angle of isosceles trapezium is always equal. You have to always learn that the base angle, the angles which are lying at the base, they are always equal, which means that opposite angle, the vertex angle will also be equal among themselves. So here two different type of trapeziums are there. First is when there is a single pair of parallel side. Here only, suppose if I name it as ABCD, where AB is parallel to CD, then it is called as isosceles trapezium. Always remember, quadrilateral with only one pair of parallel side is called as trapezium. And if a trapezium where one pair of parallel side is present, although here non-parallel sides are not equal, but when non-parallel sides also become equal, then it is called as isosceles trapezium. In isosceles trapezium, when the word isosceles trapezium is mentioned, it means that their non-parallel side will always be equal. And if a non-parallel side is equal, then you will see that trapezium is called as isosceles trapezium. And the property of isosceles trapezium is that the base angle of isosceles trapezium are equal. Due to that, the angle lying at the vertex also become equal among themselves. The base angle will be equal and the angle which are lying at the vertex will also be equal, or angles lying at the top, not at the, actually call it vertex, because vertex where two line meets in the triangle, do we see that? So angle at the top will be equal and angle at the base will be equal. So when there is isosceles trapezium, it means angle at the bases are equal, and if only one pair of parallel side is present, then it is called as simple trapezium. If you see a quadrilateral with only one pair of parallel side, that is called as trapezium. And if the non-parallel sides of trapezium are equal, that is called as isosceles trapezium. And in isosceles trapezium, base angle of isosceles trapezium are always equal. This is the first type of quadrilateral. Now, a quadrilateral with two pair of parallel sides is called as parallelogram. Quadrilateral with two pair of parallel sides, it means opposite sides will be parallel. A, B, C, D. This side will be parallel to this side and this side will be parallel to this side. When two pair of parallel sides are present in the quadrilateral, that is called as parallelogram. And in parallelogram, properties are that opposite sides are equal, opposite angles are equal, sum of two adjacent angle makes it 180, and diagonals bisect each other. It means this half is equal to this half, and this half are equal. It means AB equals to CD and AD equals to BC. That's the first part. Opposite sides are equal, opposite angles are equal. Angle A equals to angle C, angle B is equals to angle D. Adjacent angles are supplementary. A plus B equals to 180, B plus C equals to 180, C plus D equals to 180, and D plus A equals to 180. And the fourth is diagonals bisect each other. OA equals to OC, OB equals to OD. These are the four basic property of a parallelogram. Using this property, we have already solved questions from exercise 3.2, and some additional questions are also being solved there. You may just recap all the same. So this is quadrilateral with two pair of parallel sides is called as parallelogram, whose opposite sides will always be parallel. And properties of the same will be opposite sides are equal, opposite angles are equal, adjacent angle, sum of adjacent angle is equals to 180, and diagonals bisect one another. This is second quadrilateral, which we call it as parallelogram. Now parallelogram whose interior angle is 90. Parallelogram whose interior angle is 90 is called rectangle. Now when you see that if a parallelogram whose interior angles become 90, this angle, if any one angle become 90, then rest of the angle will automatically become 90. Then this is called as rectangle, and rectangle follows all property of parallelogram, follows all property of parallelogram. All property means opposite sides will be equal, opposite angle will be equal, sum of adjacent angle 180 degree, and diagonal bisect each other. Along with that, one special property of rectangle is AC is equals to BD. These two diagonal, as half of the diagonals are also equal, but other than that, whole diagonals are equal, which means to say that if any intersection point is there, then that will be equidistant from all the vertex. If our intersection point, if I take it as O will be equidistant from A also, B also, C also, D also. Using this, there is one question which you will solve in exercise 3.4. That is actually the last question of the exercise. You will see that there we are going to use this particular property of rectangle, where we need to show that O is equidistant from three different points. So always remember, rectangle although follow all property of parallelogram, other than that, one special property is that of rectangle, that the diagonals of rectangles are equal. And although the diagonals bisect each other, as it follow the property of parallelogram, so diagonals are equal also, which means that whatever the intersection point of diagonal will be there, that will be equidistant from all the vertex of that rectangle. This is the third one. Now if I go to the next one, that is parallelogram whose adjacent sides are equal. Parallelogram whose adjacent side is equal is called rhombus. If the adjacent side of a parallelogram becomes equal, that is called as rhombus. So rhombus is also a special type of parallelogram. See, I have discussed three quadrilateral. So quadrilateral, you have seen that a single pair that will be formed trapezium, single pair of parallel side, If there is two pair of opposite side parallel, that is parallelogram. Now parallelogram whose interior angle becomes 90, that is rhombus. Parallelogram whose adjacent side is equal, so that is called as rhombus. If adjacent side equal, which makes it all four side equal, and due to all, so rhombus is also parallelogram which follows all the property of parallelogram. It means here also opposite angles will be equal, sum of two adjacent angle is 180 degree and diagonal bisect each other. Other than that, one special property is that although its adjacent side equal, that makes it all four sides equal. All four sides equal, and diagonals are perpendicular bisector. It means AC is bisecting BD perpendicularly. It means wherever they will meet, they will automatically forms 90 degree. So this is that quadrilateral where diagonals bisect at 90 degree. That's why it is called as diagonals are perpendicular bisector. Perpendicular bisector. That's why it is called as diagonals are perpendicular bisector. So rhombus is that quadrilateral whose diagonals are perpendicular bisector. So this is rhombus. Repeating again, a parallelogram whose adjacent sides are equal, that is called as rhombus. Rhombus also follow all the property of parallelogram. Here due to adjacent side equal, which makes it all four side equal, and the special property of the same includes that the diagonal bisect at 90 degree, which means that diagonals are perpendicular bisector. Although the diagonal bisect each other, it means diagonal are bisecting itself, but here also as in rhombus it will bisect at 90 degree. So diagonals of rhombus are called as perpendicular bisector. And the next is parallelogram with adjacent side equal and interior angle as one interior angle as 90 degree is called square. So a square is that quadrilateral which follow all the property of parallelogram, rectangle as well as rhombus. You will see square is only that quadrilateral which holds all the property of parallelogram, all the property of rectangle as well as all the property of rhombus and rectangle. So square, if you see that as it says that adjacent side equal, which makes it all four side equal, and one interior angle 90, which means all interior angle becomes 90. So rhombus is only four sided regular polygon. Neither the rectangle nor the rhombus nor the parallelogram is said as regular polygon. Square is only called as regular polygon. It is only the four sided regular polygon because here all four sides are equal and all interior angles are 90. So the special property of rhombus includes that although all sides are equal, all four sides are equal, all four angles are equal, and diagonals follow all the property of rectangle as well as rhombus. So here diagonals are equal also and perpendicular bisector also. So diagonals are equal and perpendicular bisector. It means whole complete diagonal will be equal and part of the diagonal will also be equal, OA, OB, OC, OD, and diagonal will be bisect at 90 degree also. So square is only that quadrilateral whose diagonals are equal and perpendicular bisector. This is most important property of square, that it follow all the property of parallelogram, rectangle, rhombus, all. This is the fourth one or might be fifth one, and the last is kite. Now kite is a special type of quadrilateral which has two adjacent sides equal, two pair of adjacent side equal. Here this side and this side equal, this side and this side equal, and diagonal bisect at 90 degree. That is that kite. In kite, two pair of adjacent side equal, diagonal bisect at 90 degree. Diagonals are diagonal bisect at diagonal where the diagonal one of the diagonal bisect each other. Like this diagonal will bisect this one. If I name it as A, B, C, D, we'll say it as AC bisect BD. BD is bisected, it means this part of line is equals to this part. So AC will bisect other diagonal. So it is called as the diagonal of a kite bisect other. Diagonals are perpendicular to one another and the one of the diagonal bisect the other. Diagonal AC bisect diagonal BD and one of the diagonal bisect other diagonal, and two pair of adjacent sides are equal. Two pair of adjacent sides are equal. These are the recap of all the properties which we are going to use in this fourth exercise. In the next video, I'll try to solve the exercise 3.4. Till the time, stay safe, stay happy. Thank you.